Good morning, precalc fans. How we doing this fine Tuesday morning? It's a sunny day outside. Not gonna be too warm outside, but it's sunny outside at least, which is nice compared to what it was yesterday. All my hair was blowing all over the place and all that wind that was out there. So, sunny out there. Hope everybody's doing well in your household. Once again, if you have any questions about anything, please do comment. Send me a comment. I'll answer any questions that you have the next day on any type of homework problems. Just make comments to me and I'll do what I can do in regards to make this as easy as possible for you. Today we're going to talk about arc length, the arc length in the area of a sector, and also we're going to talk about some angular velocity. So this is new in regards to trig. Yesterday we talked about degrees of rotations, reference angles, and radians. Okay, and that should be all review for us. Today we're going to talk about some little bit different things that we did not go in trig class, which is fine. It gives us a little bit different thing to look at. There's not many new things that we will go over in regards to trig, but this will be one that we go through today. When we talk about an arc length, it's a number of radians in degree measure. Okay, when we talked about arc length, arc length is your number of radians of a degree measure. Okay, once again, as we talked about in trig class, they're synonymous with each other. Okay, if we talk about arc length, we talk about radians. If we talk about number of radians, we also talk about the arc length. Okay, but this is on a unit circle. This is on a unit circle. And if you remember a unit circle, you have a radius of 1 unit. You have a radius of 1 unit if you're on a unit circle. So what we have here is we have a radius of 1 unit. Okay, here is a circle. Okay, its center point is at the origin. What is the arc length for a 60-degree angle? Well, if I would take an angle here and rotate it 60 degrees, so I'm going to take this and rotate it 60 degrees. That's a rotation of 60 degrees. What we want to find is we want to find the arc length of this unit circle, on this unit circle, for an angle that's rotated 60 degrees. Okay, so what we have here is we want to find the measure of this right here. Well, if it was a straight line, I could hold my straight line ruler or straight edge up to that and measure it out. But I don't have a straight edge here. So how do I find the measure of that arc right there? Well, what we talked about here is the arc length is your number of radians on a unit circle. The number of radians. So if I take a look at 60 degrees, 60 degrees is equal to how many radians? That is correct. That is the value of pi over 3. Pi over 3 radians. That's the number of radians in 60 degrees. Well, what this talks about here, when we talk about arc length and radians, they're synonymous with each other. That means my arc length here is also going to be pi over 3 units, whatever our units is. Now, if I wanted to, I could clickety-clack that through the calculator and take my value of pi and divide it by 3, and I get 1.047. And that's an approximate value because I'm approximating the value of pi. So we could find our arc length on this unit circle by just looking at the radian measure. Well, what happens when we take a look at a unit circle or a radius of 4 units? Okay, what if we have a radius of 4 units like we have over here? So what we're looking for here is taking my angle taking my ray here and rotating this 60 degrees, just like we did before. 60 degrees. Rotate it 60 degrees. We want to find what this arc length is now. What will be that arc length for 60 degrees? Well, one thing that we could do is when we talk about arc length, we can also talk about the circle, the idea of a circle. If I have a circle with a radius of 4 units, what is the circumference of that? Well, the circumference is calculated by 2 times pi times our radius. So what we have here is that we have a value of 4. So we have 2 times pi times 4, which gives us a circumference of 8 pi units. Well, if I take a look at 60 degrees, what fractional part of a circle is 60 degrees? Well, a total circle, an entire circle, is 360 degrees. Okay, we want to just take a look at 60 degrees of that 360 degrees. So what we're looking for is a fractional part of 60 divided by 360, which is 1/6 of the circle. 60 degrees is a total of 1/6 of the circle. So what we want is 1/6 of 8 pi. Okay, when I have 1/6 of the circumference, of means to multiply. So we have 1/6 times 8 pi. So we have 8 pi over 6, which reduces down to 4 pi over 3 units, which is approximately equal to, and once again, I can clickety-clack, 4 times, times pi divided by 3, and we get 4.189. units. Well, let's just take a look of what we came up with here. I have 4 pi over 3. Well, if I take a look, here's this pi over 3 again that we had up here. This pi over 3 is what we had up here. Well, if I take a look here, I have the value of 4, which is our radius. Our radius is 4 units. So we have 4 times pi divided by 3 units. So I have my radius, and this here is the number of radians. So my arc length can be calculated by our radius times our degree theta in radians. So our arc length S can be calculated by our radius times our arc length in radians. Which I like to use the X because what we talked about in trig class, when I have theta, I'm dealing with degrees. When I have X, I'm dealing with radians. So I like to use the value of X there a little bit more. When we talk about a sector is a region in the interior of the circle bounded by 2 radii. Bounded by 2 radii. And what we're going to look to do is we're going to look to calculate the area of this sector. Okay, well what I have is I have a rotation of 120 degrees. Now the arc length is just the circumference of the circle. But when we talk about the sector, we're talking about calculating all this area right here. So we're looking for the area of the sector. So we're looking to find everything else inside here. We're looking for the pizza, really. When we're talking about arc length, we're just looking at the crust. Now we're talking about the good stuff, the pizza, that we can eat up. What is the area of that sector? Well, once again, I could take a look at, well, how do I calculate the area of a circle? The area of a circle. Well, how do I calculate the area of a circle? That's a thinker. Well, the circumference 2 times pi times radius, the area is calculated by pi times our radius squared. Pi times our radius squared. And what we have here is, once again, we have 2 radii. They have a radius, a length of 6. This here is a sector because I'm bounded by 2 radii. Well, the entire area of the circle, if I look at the entire area of the circle, my radius is 6. My area here is going to be pi times 6 squared, or 36 pi. That's the area of the entire circle. Well, let's take a look like we did up above, 120 degrees. What part of the circle is 120 degrees? So we can look at this fractional part of 120 divided by 360. This is 1/3 of the circle. So what we want here is the area of the sector, which is going to be 1/3 of the area of the circle. So we can take our fractional part, which is 1/3 times 36 pi, which gives me a value of 12 pi, let's see here, feet squared. Now once again, it's more than acceptable to leave it in terms of pi, but if you really want to multiply by pi and get a number, we get 37.699 or 37.7. Feet squared. So we have the area of a sector is equal to the area of the circle times its fractional part. Now there is also another way of calculating this. I'm not too in tune to it. I like this a little bit more because it just goes back to basic mathematics rather than trying to memorize a different part. And your fractional part, is equal to your degree measured divided by 360. Or your radian measured divided by 2 pi. I pretty much like to keep it in degree measured divided by 360 because it keeps it a little bit easier in my brain. Okay, I can think through this a little bit better. So if I'm talking about the area of the sector, I have the area of the circle times the fractional part. And if I want to take a look up here also, when I look at arc length, I can think of it as radius times my degree measure in radians, or I can also think of this as fractional part times the circumference of the circle. So either way is correct thinking about this. I sort of like the fractional part idea. It's a little bit easier in my brain. It makes it a little bit easier for me to think through the process. But once again, if I talk about your number of radians, your radius squared times 1/2. If I look at 120 degrees, the number of radians this is, we have pi over 180 is equal to x over 120 using our little conversion. So we have 120 pi over 180. These cancel, so we have 12 pi over 18. taking 6 out of both of them, we have 2 pi over 3. So I can calculate the area of my sector by taking 1/2 my radius squared, which is 6 squared, times 2 pi over 3. So I have 1/2 times 36. This gives me 18 times 2 pi over 3. We can cancel 1 and 6. 2 times 6 gives me the 12 pi feet squared also. Either way is correct. I don't mind to do it. You do it in either way. I don't like memorizing formulas if I don't have to. If I can think about the entire circle and multiply it by its fractional part, I'm happy with that. Find the area of the circle with a radius of 5 feet for a degree measure of 240 degrees. Well, I want you to find the arc length also. I want you to find the arc length and the area of the sector. Okay, we have a central angle of 240 degrees. We have a radius of 5 feet. What I want you to do, okay, I'm going to explain what I want you to do, and then you can turn it off. But I want you to work this problem on your own. So to work it on your own, I want you to turn off your YouTube video first. Work the problem, and then turn the YouTube video on to see if you've done it correctly. So at this time, go ahead, turn off your video, work the problem, turn it back on to see if it's correct or not. The circumference of the circle is equal to 2 times pi times the radius. Radius is 5 feet, so the circumference is 10 pi. Now my fractional part is equal to 240 over 360. I could take a 0 off both of these, take 12 out of top and bottom, so my fractional part is 2/3. So the arc length, my arc length S is going to equal my fractional part times the circumference of the circle. So we have 2/3 times 10 pi, or 20 pi over 3, and we're talking about feet. Now, if you want to change this to a radian measure and go that route too, that would be fine. The area of the sector, well, let's find the area of the circle. The area of the circle is calculated by pi r squared. My radius is once again 5 feet. So we have pi times 5 squared, so we have 25 pi. Then to find the area of the sector, we can take our fractional part and multiply by the area of the circle. So my fractional part, once again, is 2/3, 25 pi. So I can multiply the 25 and 2 to give me 50 pi over 3. And once again, don't forget your feet squared, your units squared. So this is arc length and area of the circle. Linear velocity. Linear velocity. It's your total distance divided by time. This is your average linear velocity. Take your total distance divided by time. Well, what we have here is my distance is going to be my arc length. And my arc length is calculated by pi times my number of degrees in radians, or my fractional part times the circumference of the circle. So that is my distance that I'm talking about here. So if I talk about linear velocity, what this converts into is your arc length divided by time. What is my arc length divided by time? Which is S divided by T. And once again, if I'm going too fast, just hit your pause button. I will stop talking if you hit your pause button. Okay, you can shut me up that way. Okay, and then turn it back on once you catch up. So my linear velocity is my arc length divided by time. Angular speed, how fast you are going around a circle in an angular velocity. The symbol that we use for angular speed is omega. Okay, it is a curly W. This is omega. This is your number of radians that you have gone per amount of time. What is your number of radians that you have per amount of time? And once again, if you want to use X here, that is fine. My arc length is my radius times this number of radians. So the radians are calculated by arc length divided by radius. Okay, so our arc length divided by radius. So if I want to find my angular velocity, okay, I have my arc length divided by my radius, and I'm dividing this by the amount of time, which turns into arc length divided by radius times 1 over time. So we have arc length, radius divided in time. Angular velocity, I more or less just look at your number of radians that you're dealing with divided by your amount of time. What happens to this then when we make a conversion is your velocity is equal to your radius times your angular velocity. So your average velocity is equal to radius times your angular velocity. The angular speed is in radians per second or revolutions per second. For the compute an angular velocity, you must be in radians per unit time. So if we take a look at 5 revolutions per minute, what is the radians per minute? Well, the number of revolutions. If I take a look at 1 revolution, that's equal to 2 pi radians. Your 1 revolution, once again, 1 time around the circle, is equal to 360 degrees, which is 2 pi radians. So if I go 5 revolutions, I've gone around the circle 5 times. Okay, I've gone around the circle 5 times. So the number, if I have 5 revolutions per minute, each revolution is 2 pi radians, so I could take by 5 times my 2 pi, so I had turned this into 10 pi radians per second. 10 pi radians per second. Okay, we're going to leave it at that. I'm not going to worry about this problem at this point. Don't worry about the problem. What I'm more worried about, if I can do my angular velocity, do a little bit of working with the idea of area of the sectors and arc length here, and you can deal with some angular velocity. That's all I'm going to worry about in regards to this section. If we were in class, I'd probably go a little bit more further extended into this, but we're not, but that's fine. That's fine. Take a look at the idea of radians, take a look at the idea of arc length and area of the sector, and also dealing with the angular velocity. This here is a key idea to remember. When I talk about arc length is equal radius times your amount of rotations or radians, or dealing with this, what is my number of radians per time? What is my radians per time? When I'm dealing with an angular speed, and that's omega. That's all I'm really going to worry about in regards to the ideas we have here. And then we have a linear velocity is equal to radius times your angular speed. My linear speed is equal radius times your angular speed. I would know this one also and be able to refer to that also. Be able to manipulate this. So if I wanted to, this will also go into angular velocity is equal to a linear velocity divided by our radius, dividing both sides by r. You have some homework problems due. I gave you some solutions to the homework also. Please work on the solutions. Once again, try to FaceTime some people, try to talk to some people, get some socializing going on here. I miss not having you guys in class. I miss you guys. I wish we were back into a normal routine. Continue your social distancing. They say it is making a difference. So continue your social distancing. Take care of yourself. Try to get outside while it's sunny outside. Get some work done. Maybe you have to mow the yard for your mom and dad. That would be good. Go out and mow the yard. I'm going to go out and split wood today. So it's a beautiful day to be able to go out and do things like that. Be safe. If you have any questions or comments, please do email me. I'll be more than happy to address them the next day. Not anything else. Adios. Have a great day, folks.